Hello everyone. So in this lecture we will be doing introduction to three-dimensional geometry from NCERT. So like always notes will be available below the video as a Google Drive link. So we will revise some things that we have already done in the chapter vectors. For example, we have done how to define a vector. We have defined, for example, we can define OP vector here in this figure. Let's say the coordinates of this point are x, y, z. The OP vector, which is the position vector of point P, and let's say I will also call it the R vector, can be defined as xi cap, yj cap plus zk cap. So you can imagine कि यहाँ पे हम triangle law लगा रहे हैं and you have moved from O to P. For example, आप पहले x direction में x distance cover कर सकते हैं, right? Then you can cover y along y and then you can cover z along z and you will come to this point, right? So this is like xi cap plus yj cap. This will give you this side of the triangle, right? And then इसमें अगर आप क्या ऐड कर दें zk cap in the figure and that will give you the OP vector, right? Triangle law से we say xi cap, yj cap, zk cap. We have also learned कि magnitude of this R vector is nothing but square root of x square plus y square plus z square. We have defined direction ratios. Direction ratios for this vector are x, y, z. So these are the x, y, z coordinate. So NCERT में इसको अलग तरीके से मेंशन किया हुआ है. NCERT में ABC लिखा हुआ है, but don't confuse. So NCERT में they are also writing R vector as A I cap plus B J cap plus C K cap. So direction ratios इस केस में क्या हो जाएंगे? ABC. We have also defined direction cosines, which are cos alpha, cos beta, cos gamma, and they were defined as L, M, and N, and they had a property which they satisfy. So the property is L square plus M square plus N square is 1. And these were all defined in the last chapter, right? If you look carefully in this diagram, so cos alpha can be defined, for example, cos gamma define करते हैं. So if we can clearly look in this triangle, so मैं इसको red mark कर देता हूँ ये. So OZP, right? ठीक है. तो एग्जाम्पल, तो यहाँ पे हमने cos अल्फा कितना डिफाइन कर रखा है या फिर L की वैल्यू. तो दिस वाज x by r. M की वैल्यू cos बीटा which is y by r, and N की वैल्यू cos gamma which is z by r. And if you are using point ABC, points का नाम अगर आप ABC यूज कर रहे हैं x y z की जगह, then you can define them as a by r, b by r, c by r, and where r is nothing but the magnitude of that vector, right? ठीक है. So magnitude of r vector को हम क्या बोलते हैं? r बोलते हैं. Without, अगर आप किस पे कोई वेक्टर का साइन नहीं लगा रहे तो this is same as mod of r. So why is that? For example, look into the given figure, right? So in triangle, OZP, so this is 90 degree, angle Z is 90 degree. So cos theta, so cos gamma can be defined as base, which is OZ, divided by hypotenuse, which is OP, and this is Z by R, right? Okay. In same way, you can define other two also. So these are already being done in the previous chapter, right? ये सब चीजें हमने पहले भी cover करी हुई हैं. So let's go back to the NCERT and अच्छा हाँ तो बट अगर मुझे डायरेक्शन कोसाइंस अगर किसी लाइन के डिफाइन करते हैं, सो डायरेक्शन कोसाइंस ऑफ अ लाइन, सो देयर इज अ डिफरेंस बिटवीन डायरेक्शन कोसाइंस ऑफ अ वेक्टर, ठीक है, ऑफ अ वेक्टर. सो दीज आर डायरेक्शन कोसाइंस ऑफ अ वेक्टर. सो वेक्टर आप इमेजिन करिए कैसा दिखता है, ऐसा दिखता है, राइट? इट हैज अ यूनिक डायरेक्शन, राइट? सो द यूनिट वेक्टर विल बी यूनिक. सो दिस विल बी यूनिक क्योंकि देर इज ओनली वन डायरेक्शन जो उस डायरेक्शन में है. बट डायरेक्शन कोसाइंस of a straight line, so of a straight line. So if I have a straight line and इसके मैंने आपको डायरेक्शन कोसाइन दे दिए L, M and N, but you can imagine there will be two answers, right? Plus and minus, right? ठीक है, both should be allowed क्योंकि line extends in both directions, right? So because the line extends indefinitely in both directions, so which is like r cap and minus r cap wala direction. So now let's look into NCERT. So as NCERT also says कि अगर हम लाइन का डायरेक्शन उल्टा कर देंगे तो द एंगल इट विल मेक with x axis will be pi minus a, angle with the y axis will be pi minus beta and z के साथ pi minus gamma, and cos of pi minus alpha क्या होता है, minus cos alpha, तो आंसर क्या आएगा minus है. And cos of pi minus beta क्या होगा, minus cos beta which is minus n. So both are allowed, ठीक है, क्योंकि लाइन का डायरेक्शन ऐसे भी हो सकता है, इधर भी हो सकता है. So let's move to next page. So we have already looked into this diagram, and now direction ratios are also called direction numbers, and these are the three numbers which are proportional to direction cosine. So as you can see हमने define किया हुआ है कि there is a relation between A and L. So A is a direction ratio and L is the direction cosine, and we have defined already कि they are proportional, right? L is proportional to A, so I can also say A is proportional to L, right? So you can also say A is proportional to L, and proportionality constant क्या होता है यहाँ पे, R होता है, right? ठीक है, you can say K times, but you will find the result is R times L. And similarly B is proportional to M and C is proportional to N, and we find B is R times N and C is R times N, and there are two equations, right? कि A square plus B square plus C square कितना होता है, R square, right? Because length of that vector will be defined by square root of square of the direction ratios or direction numbers, and we have also defined L square plus M square plus N square is 1, right? So now लेट्स लुक इनटू सो अगर आपके पास किसी लाइन का डायरेक्शन गिवन है कि इफ यू आर गिवन कि ए बी सी आर ये क्या है डायरेक्शन रेशोज या फिर डायरेक्शन नंबर्स, देन आप इससे इसका यूनिट वेक्टर बना सकते हैं. यू कैन डिवाइड बाय रूट ऑफ ए स्क्वायर बी स्क्वायर सी स्क्वायर. And please remember answer is plus minus lmn for the direction of the line, right? Okay, this is the direction of the line. And which will say your result is plus minus a by root of a square plus b square plus c square, which is a by r. L is a by r, right? And this is b by root of a square plus b square plus c square, and c by root of a square plus b square plus c square. So direction of the line या फिर direction cosines of the line, right? Okay. So now let's see direction cosines of the line passing through 2 points. So next topic here is direction cosines of a line passing through 2 points. So let's say first point is P, which is x1, y1, z1, and second point is Q, which is x2, y2, z2. So we can define the PQ vector या फिर QP vector. But line कैसा होगा? So line can be in any direction. Right? Line can be in any direction. It can be in the direction of PQ cap or minus PQ cap. But let's define for now PQ vector define करते. So PQ vector is nothing but final minus initial के definition से x2 minus x1, right? I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, and length of the PQ vector is square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So PQ के जो वेक्टर के जो components है x2 minus x1, so these are the direction ratios, right? So direction ratios क्या होंगे इस लाइन के? So they will be plus minus ABC, right? Plus minus ABC, क्योंकि डायरेक्शन रेशियो भी इससे वो डायरेक्शन में कुछ भी हो सकता है. एंड ABC क्या है इस केस में? So if you notice, so this is A, B and C, and they define कि आप x में कितना मूव किए, y में कितना मूव किए, and z में कितना मूव किए, because you can redraw this, you redraw this PQ vector and bring it again to origin, right? ठीक है, and now you can define cos, क्योंकि हम vectors को redraw कर सकते हैं, right? ठीक है, so this is let's say P dash Q dash. So मैं PQ vector को उठा के origin पे ले आया, and this is because of the properties of vectors. Vectors can be redrawn. And now we can define cos alpha, cos beta, cos gamma basically, या फिर ABC also. So ABC इस केस में क्या होंगे? So that depends upon initial and final point, right? So these are x2 minus x1. So comma y2 minus y1 comma z2 minus z1. And what about the direction cosines? So they will be plus minus lmn, and lmn के लिए हमें क्या करना पड़ेगा? A by r, B by r, C by r. So I mean, this is r, right? Because this is the length of the vector, and we can define it as plus minus 1 by, we can take so हर जगह डिवाइड करने से अच्छा है, इतना बड़ा नंबर लिखने से अच्छा है. So let's write पहले x2 minus x1, y2 minus y1, z2 minus z1. बट ये सब किससे डिवाइड हो रहे हैं? लेंथ ऑफ पी क्यू से, लेंथ ऑफ पी क्यू. So what is the length of PQ here? So length of PQ is defined as square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. And these are like plus minus a by r, b by r, c by r, right? So r यहाँ पे क्या था? Length of PQ, right? So these are the direction cosines of a line passing through 2 points. ये रहे. And this is the where condition, where we have the value of PQ bar, right? PQ vector का magnitude. So now let's look into some examples of NCERT. So example 1. So if a line makes 90 degree, 60 degree and 30 degree with positive x, y, z axis, find the direction cosines. So direction cosines is defined as plus minus. तो ये लाइन है, ये वेक्टर. तो देखो ये लाइन है, तो while I am writing plus minus. वेक्टर होता तो हम plus minus नहीं लिखते, right? LMN. And the result is plus minus cos alpha, cos beta, cos gamma. Cos 90, cos 60, cos 30, which are 0, half and root 3 by 2. Okay, so let's move to next question. So I have written plus minus, NCERT ने नहीं भी लिखा तो it doesn't matter. So ये रहा. तो उसने डायरेक्शन कोसाइन निकाले हैं 0, हाफ एंड रूट 3 by 2. So let's move to next question. Example 2. एक लाइन है जिसके डायरेक्शन रेशियोज गिवन है. तो डायरेक्शन रेशियोज ए बी सी गिवन है, राइट? तो which are 2 minus 1 2. We have to define L M and N. तो डायरेक्शन तो हम क्या निकाल लेते हैं? पहले R निकाल लेते हैं. R is root of a square plus b square plus c square. So 2 square plus minus 1 का square plus 2 square, and this is root 9, which is 3. And I can define direction cosines now, which are L, M and N, and I should keep plus minus. And L क्या होता है? बिकॉज यहाँ पे लाइन गिवन है, राइट? सो आई एम कीपिंग प्लस माइनस इन अ लाइन. अगर वो वेक्टर गिवन होता, वेक्टर का डायरेक्शन सेम होता है जो भी गिवन होगा डायरेक्शन रेशियो का, बट लाइन में प्लस माइनस आर अलाउड, राइट? सो प्लस माइनस, एंड यू कैन ऑल्सो कीप प्लस माइनस हेयर ऑल्सो, राइट? डायरेक्शन रेशियोज में भी. सो यहाँ पे वी विल फाइंड a by r, b by r, c by r. So our result is plus minus 2 by 3, comma minus 1 by 3, comma 2 by 3. Okay, so let's check this. And so 2 by 3, minus 1 by 3 and 2 by 3. So let's go to example 3. Find direction cosines of a line passing through these 2 points. तो पहले हम क्या निकाल लेते हैं? डायरेक्शन रेशियोज निकाल लेते हैं. तो हाँ, डायरेक्शन रेशियोज निकाल लेते हैं. तो डायरेक्शन रेशियो of a line passing through 2 points क्या होता है? So these are x2 minus x1, comma y2 minus y1, comma z2 minus z1. And I should also keep plus minus outside. because डायरेक्शन उल्टा भी हो सकता है. So plus minus. So x2. So this is I'm taking as the second coordinate 1 2 3 and minus 2 4 5 को मैं first ले रहा हूँ initial point. So 1 plus 2 comma 2 minus 4 comma 3 plus 5. So this is plus minus 3 minus 2 and 8. So अब डायरेक्शन कोसाइन निकालना है तो we should find r which is root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. पूरा लिखने की जरूरत नहीं, you can just do 3 square plus minus 2 का square plus 8 square because आपने x2 minus x1 y2 minus y1 z2 minus z1 already calculate कर लिया. So this is 9 plus 4 plus 64, so which is 68 and 77. So now we can define direction cosines as plus minus x2 minus x1 by r, right, comma y2 minus y1 by r, comma z2 minus z1 by r. So we already have most of the values, so we will just keep plus minus x2 minus x1 कितना था 3 divided by root 77, comma minus 2 divided by root 77, comma 8 divided by root 77. So let's check the answer. Here are 3 minus 2 and 8 and there is a plus minus outside. So next is example 4. It says find direction cosines of x, y and z axis. So अलग अलग है, there are 3 questions, right? ठीक है, पहला क्योंकि अलग ये 3 अलग अलग लाइंस है, डायरेक्शन कोसाइंस ऑफ x एक्सिस क्या होगा. So this will be, हम क्या निकाल रहे हैं, LMN which is cos alpha cos बीटा cos गामा, राइट. ठीक है, डायरेक्शन कोसाइंस पहले लिख देते हैं ऊपर, LMN पहले ही एक बार फॉर्मूला लिख देते हैं, which are cos alpha cos बीटा cos गामा, cos alpha cos बीटा cos गामा. तो रिजल्ट डायरेक्ट लिखेंगे बट अल्फा बीटा गामा लिख लेते हैं. तो अल्फा कितना होगा इसमें, बीटा कितना होगा और गामा कितना होगा. सो व्हाट इज द एंगल मेड बाय x axis with x axis, so that is 0 degree, right? What is the angle made by x axis with y axis, so beta, this is 90 degree, and gamma कितना होगा 90 degree. This is the angle made by x axis with z axis, right? So this is cos 0 comma cos 90 degree comma cos 90 degree, which is 100, and you can keep plus minus, nobody is stopping you क्योंकि x axis में minus x axis भी आता है, right? ठीक है, so both of these should be allowed, but as you can see in the NCERT, answer should be given as 100. ठीक है, 100. And similarly direction cosines of y axis कैसे होंगे. So direction cosines of y axis will be cos 0 90, क्योंकि x axis के साथ 90 डिग्री बनाता है, y axis के साथ कितना बनाता है 0, comma cos 90, so which are 0 1 0. And similarly direction cosines of z axis क्या होंगे. So these will be 0 0 1, right? So let's move to last example. So show that these 3 points are collinear. तो हमने ये collinearity वाला क्वेश्चन 2 मेथड से ऑलरेडी करा हुआ है इस चैप्टर में. So we have done कि हमने AB वेक्टर निकाल के हमने क्या निकाला था, मैग्नीट्यूड ऑफ AB, राइट. हमने BC वेक्टर निकाल के वी ऑल्सो फाइंड मैग्नीट्यूड ऑफ BC, एंड फॉर एग्जांपल हमने AC वेक्टर निकाल के वी ऑल्सो फाइंड मैग्नीट्यूड ऑफ AC। एंड अगर दो छोटे वाले numbers का sum, if it was coming out to be the larger one, right, then they were collinear, right? For example, if AB plus AC, right, for example in this question you will find कि AB का magnitude plus AC का magnitude will be equal to BC magnitude, so you can say कि ये तीनों points क्या होंगे, collinear होंगे, ठीक है? ये length plus ये length, it will be equal to this length। हमने second method सीखा था कि I can find AB dot BC, sorry, cross product, so AB क्रॉस प्रोडक्ट में if हमने सेकेंड मेथड सीखा था AB क्रॉस हम BC वेक्टर निकाल सकते हैं, एंड अगर ये कितना आ गया, नल वेक्टर के इक्वल आ गया, तो दैट मीन्स AB इज कोलिनियर विद BC, राइट? AB इज कोलिनियर विद BC, एंड इससे भी प्रूव हो जाएगा तीनों क्या है, कोलिनियर है। देन हमने एक थर्ड मेथड भी सीखा था इस चैप्टर में, तो कोलिनियरिटी का कंडीशन कि इज AB वेक्टर इज इक्वल टू लैम्डा टाइम्स BC vector, right? So condition for collinearity. So this was the easiest one. So now in this chapter, NCERT is trying to solve it using the method of direction ratios. So you can, so fourth method can be कि अगर दो वेक्टर्स या दो लाइंस, so so if this A and this are collinear, then you can say कि ये जो AB वेक्टर है और ये BC वेक्टर है, you can say कि इनके डायरेक्शन रेशियोज क्या होंगे, प्रोपोर्शनल होंगे। सो फॉर एग्जांपल A1 B1 C1 ये आ रहा है इसके, एंड A2 B2 C2 इसके आ रहे हैं BC वेक्टर के, एंड यू कैन प्रूव कि डायरेक्शन ratios of AB vector will be proportional to BC vector। so डायरेक्शन, क्योंकि इनका डायरेक्शन तो सेम ही होगा एंड ये प्रोपोर्शनल होंगे, डायरेक्शन ratios of AB vector will be proportional to direction ratios of BC vector। so चार मेथड किए, एंड माय फेवरेट वन इज थर्ड मेथड कि आप AB वेक्टर को लैम्डा टाइम्स BC वेक्टर लिख दीजिए एंड फाइंड द वैल्यू ऑफ लैम्डा, एंड लैम्डा तीनों कंपोनेंट से सेम आएगा। बट लेट्स सी, सो इसको अब करते हैं डायरेक्शन रेशियो से। सो हम drs ऑफ AB वेक्टर क्या होंगे, तो दीज आर x2 minus x1 y2 minus y1 z2 minus z1। सो AB वेक्टर क्या होगा, 1 minus 2 comma minus 2 minus 3 comma, so it's like मैंने AB वेक्टर लिखा है, बस कंपोनेंट्स लिखे हैं, राइट, उसके। so I have not written I cap j cap k cap, 3 plus 4, and this comes out to be minus 1 minus 5 and 7। let's find drs of BC vector। so x2 minus x1, so C वाले coordinates, so 3 minus 1 comma 8 plus 2 comma minus 11 minus 3, so this is 2 comma, so these are ABC, A1 B1 C1, and these are A2 B2 C2, so 2 comma 10 comma minus 14, so we can find A1 by B1, A1 by A2 कितना आ रहा है वो, minus 1 by 2, we can find b1 by b2, which is minus 5 by 10, which is also minus 1 by 2. And c we can also find, uh, so just a second, it should be visible now. And I can also find c1 by c2, which is equal to 7 by minus 14, which is also minus 1 by 2. So I can say drs of AB vector and BC vector are proportional. So A comma B comma C are collinear. So now let's move to our exercise, which has only few questions, 5 questions, should be done within few minutes. So if line makes these angles with XYZ axis, find its direction cosines. So direction cosines will be defined as LMN, right? So, and if you want to, you can keep plus minus. And so this is cos 90, cos 135, cos 45, which is 0, minus 1 by root 2 and 1 by root 2. So let's check the answer from the back side of the book. So here are 0, minus 1 by root 2 and plus 1 by root 2. So let's move to second question. So question says find direction cosines of a line which makes equal angles with coordinate axes. So this is the same question we have seen in the previous chapter, दो तीन बार आया हुआ है. So if the line makes equal angles, so alpha is equal to beta is equal to gamma, right? Let's say they are all equal, right? So alpha is equal to beta is equal to gamma, and let's say they are all equal to theta. So we know the condition ki L square plus M square plus N square is 1. So which is cos square alpha, so cos square theta plus cos square theta plus cos square theta is 1, and we find 3 cos square theta is 1, and cos theta comes out to be plus minus 1 by root 3. And so this is the value of L or M or N, right? Okay. And we find our direction cosines, which are L, M, N, to be cos alpha, cos beta, cos gamma, to which are cos theta, cos theta, cos theta. So plus minus 1 by root 3, comma plus minus 1 by root 3, comma plus minus 1 by root 3. And what you can do is take plus minus 1 by root 3 common if you want to, but let's see what's the result at the back side of the book. So plus minus 1 by root 3, plus minus 1 by root 3, and plus minus 1 by root 3. Okay, so we'll leave it as it is. So let's move to third question. So if you at least want to, you can keep plus minus outside. So 1 by root 3, 1 by root 3, 1 by root 3. And negative से multiply होगा, तो second answer will be minus 1 by root 3, minus 1 by root 3, and minus 1 by root 3. So if line has direction ratios ABC given है minus 18, 12 and minus 4, तो पहले r निकाल लेते हैं. So which is square root of minus 18 square plus 12 square plus 4 square minus 4 square, which is what is 18 into 18? 364 plus 144 plus 4. So 148 plus 364. Is it 364 or 324? So 18 into 18. 4, 6, 8, 14, 18. So 2, 324. So 324 plus 148, 217, 572. So maybe we can factorize it. 572. So 2. I could have taken 2 outside earlier also. But 2, 2, 8, 6, 2, 1, 4, 3. Okay. And 143. Does it come in anybody's table? But okay. So R is 2 root 143. So if we have to, we will simplify it more. So let's erase all this. So now we can define our direction cosines जो क्या है L, M and N, which are, if you want to, you can keep plus minus, which are A by R, B by R, C by R, and which are minus 18 by 2 root 143, comma 12 by 2 root 143, comma minus 4 by 2 root 143, and they are minus 9 by root 143, comma 6 by root 143, comma minus 2 by root 143. And if you want, you can keep plus minus outside. So let's check the answer. Third, तो थर्ड का आंसर नीचे 11 आ रहा है, तो क्या गड़बड़ कर दी हमने. So let's see. So did we make a mistake? Okay, I can see few of them. Well, first looks like कि हमने -4 का स्क्वायर यहाँ पे 16 नहीं लिखा एंड यहाँ पे सम गलत लग रहा है. So let's correct both of these and change the numbers. तो यहाँ डिनोमिनेटर में नंबर्स चेंज हो जाएंगे. So this is 324. That is fine. And this is 16. And this is 160. And this is coming out to be 484. Which is 4 into 121. Which is 2 into 11. Which is 22. So I have to divide by 22. So 22, 22, 22. And this is minus 9 by 11, 6 by 11 and minus 2 by 11. So minus 9 by 11, 6 by 11 and minus 2 by 11. Okay, in that order. And there is plus minus sign से multiply करोगे तो plus 9 by 11, minus 6 by 11 and plus 2 by 11. So that is also allowed. So let's move to next question, which is show that these 3 points are collinear. Fourth question. So collinearity अलग अलग तरीके से कर सकते हैं इस क्वेश्चन को. So and we will do it with direction ratios this time. कि let's say I will call this point A, this to be B, this point of C, and DRs, तो direction ratios of AB ये कितना आ रहे हैं x2 minus x1 करके, so -1 -3 -2 and then -2 -3 comma 1 -4 which are -3 -5 and -3 and DRs of BC क्या आ रहे हैं. So DRs of BC are 5 plus 1 comma 8 plus 2 comma 7 minus 1 which are 6 comma 10 comma 6. So so these are A1 B1 C1, A1 B1 C1, and these are A2 B2 C2, A2 B2 C2, and if these 3 points are collinear, then direction ratios must be proportional. So A1 by A2 is -3 by 6, which is -1 by 2. Similarly, B1 by B2 is -5 by 10, which is also -1 by 2. And C1 by C2 कितना है? This is -3 by 6, which is also -1 by 2. So from all this I can say direction ratios of AB and BC vector are proportional. So A comma B comma C are collinear. So last question of this exercise. Find direction cosines of the sides of the triangle whose vertices are these. So मैं A ले रहा हूँ 3 5 -4 and I am taking, let's say, B here, and this is -1 1 2, and C, let's say, is here, and this is -5 -5 -2. So looks all right and points are also correctly written. So हमें क्या निकालना है? डायरेक्शन कोसाइंस ऑफ द साइड्स. तो हम पहले निकाल लेते हैं DRs of AB. So DRs of AB x2 minus x1, right? So all those numbers. So AB के कितने आ रहे हैं? So फाइनल पॉइंट B है, so -1 -3 comma 1 -5 comma -4 फाइनल पॉइंट B है, so 2 plus 4. So this should be erased. तो ये वाला 2 plus 4. Okay. So these are -4 -4 comma 6 and इसका मैग्नीट्यूड निकाल लेते हैं, R निकाल लेते हैं, which is root of 16 plus 16 plus 36. So 32 and 36 is root 68. 39, ठीक है, so root 68. So I can find DRs of the direction cosines of AB now, and ये कितने आएंगे? So this will be A by R, B by R, C by R plus minus, right? So -4 by root 68 comma -4 by root 68 comma 6 by root 68, and I can keep plus minus अगर, because इस AB वाली लाइन जो है इसका डायरेक्शन इधर भी हो सकता है उधर भी हो सकता है. So लेट्स सी, फिफ्थ में एक आंसर तो ऐसा आना चाहिए, राइट? 3 आंसर होंगे फिफ्थ के. सो यहाँ पे रूट 17 के फॉर्म में गिवन है, सो मे बी वी कैन टेक 68 का आधा 39 होता है. So root of 68 को आई गेस सिंप्लीफाई कर सकते हैं. सो दिस इज 34 and ठीक है 2 root 17. So I can change all those numbers there on the right side. यहाँ पे मैं क्या लिख सकता हूँ? 2 root 17, 2 root 17, 2 root 17. So 2 root 17, 2 root 17, 2 root 17. Now it can simplify to plus minus 2 by root 17, comma minus 2 by root 17, comma 3 by root 17. Let's check पीछे कोई तीन में से एक आंसर कोई ऐसा है क्या? So minus 2 and 3. So minus 2 and 3, yes. So first one. So let's put it here. ये एक आंसर तो आ गया. And similarly, we will find BC और AC के direction ratios and उनके. So we'll do it directly. So directly कैसे करेंगे? So let's see. तो पहले हम क्या निकाल लेते हैं? Mod BC निकाल लेते हैं. ठीक है, mod BC कितना आ रहा है? So मैं BC के लिए देख रहा हूँ. So this is 5. Okay, so and what about direction cosines of BC? Direction cosines of BC. So those are x2 minus x1. So x2 minus x1 क्या आ रहा है? So minus 5 plus 1 divided by mod BC, comma y2 minus y. तो मैं इस बार डायरेक्टली डायरेक्शन कोसाइन लिख रहा हूँ, ठीक है. And y2 minus y1 which is minus 5 minus 1 divided by mod of BC, comma minus 2 divided by mod of BC. So the numbers associated are here 4. तो यहाँ पे आएगा 16. This will be 36 and this will be again 16. And this is again 68 which is 2 root 17. And I get plus minus बाहर लगा देते हैं. तो plus minus अंदर क्या है? Minus 4 by 2 root 17, comma minus 6 by 2 root 17, comma minus 4 by 2 root 17, which is plus minus 2 by root 17, comma minus 3 by root 17, comma minus 2 by root 17. So let's check ऐसा कोई आंसर अवेलेबल है क्या? ये रहा. And similarly you can calculate it for AC. So AC का calculation. So we can find direction ratios of AC and those are final point C है. So minus 5 minus 3, comma minus 5 minus 5, comma minus 2 plus 4. Those are minus 8 minus 10 and plus 2. Now I can find magnitude of AC vector also, which is square root of 8 square 64 100 plus 4. This is square root of 168 and this is 84 242. Okay, so this is 2 root 42 and we get, तो इसमें 42 के टर्म्स में आ रहा है, हाँ आ रहा है, and we get direction cosines of AC as minus 8 by 2 root 42, comma minus 10 by 2 root 42, comma 2 by 2 root 42. So this becomes minus 4 by, and plus minus बाहर लगाया था, so plus minus 4 by root 42, comma minus 5 by root 42, comma 1 by root 42. And let's match up the answer. So हमारा अंदर आ रहा है नेगेटिव नेगेटिव पॉजिटिव, राइट? बट अगर आप नेगेटिव वाला आंसर देखोगे तो दैट्स व्हाई आई कीप केप्ट प्लस माइनस, राइट? सो सिंस बोथ आंसर्स आर अलाउड, राइट? सो माइनस से मल्टीप्लाई करोगे यू गेट प्लस 4, plus 5 and minus 1. So thank you for watching. In next lecture we will be doing the next exercise ka theory, which is straight lines, equation of a line in 3 dimensions. So iska vector form, iska Cartesian form, and we'll be doing more formulas associated with it. So of course notes will be available below the video, and thank you for watching.